Hi, my name is Krishna Amaran and this is my Physics Lab 2 report. So for this lab, it was the same as Lab 1 where we examined an excess charge on one piece of clear charge tape and we created a U-tape and checked if it attracted and repelled with certain objects. And we also held two U-tapes close together and observed the reaction. So the assumptions that we made in this lab for the code that we did was that air resistance is negligible, and each U-tape had the same amount of charge evenly distributed along the length of the tape. Now for the observations and the data. So first, the length of each tape was approximately 0.2032 meters, and the distance between the tapes was 0.01036 meters, and both of these were found from the original lab. And then to calculate the original charge, which we already have from Lab 1, just to reiterate, we found the force of the electric field using mass times gravity, and then we set that equal to the force of the electric field equals K times Q squared over D squared, and then we solved for Q, which is the square root of mg times D squared all over K, and we got 4.87567 times 10 to the negative 9th coulombs. And then to estimate the net charge on the same tape but using multiple point charges, aka a line charge, instead of one singular point charge, we got 1.43373 times 10 to the negative 8th, as you can see, which is not the same calculation, and we will discuss why later on. And as you can see from lines 32 to 38 on this picture of the code here is the function to calculate an electric field from Lab 0, where you plug in the charge, the change in the distance, and then you set a calculation for the magnitude of r and r hat, and then you solve for E by doing kq over r squared times r hat. Split the top tape into many small pieces, aka point charges, and treated the bottom tape as a charged rod to calculate each specific charge on the top tape. So as you can see in line 23, that's what we did. We found the force of each charge on the top tape by the bottom tape by multiplying the charge of each point charge times the E field of the top tape by the bottom tape. Then in line 124, we summed all of these forces together, and then that's how we got the total charge, which, as we said earlier on the last slide, which we calculated. And then in lines 137 and 140, we drew the electric and gravitational force arrows, which are white and yellow respectively and are of equal and opposite magnitude. And then the green arrows, as you can see, are each of the point charge forces, which are all of equal length since they are all affected the same by the bottom tape. So in the original lab, we modeled it as a singular point charge for the tape, while in this lab, we modeled each specific point charge along the tape evenly distributed, aka a line charge. So to calculate the difference of how much this charge was changed because of how we did the calculation, we use a formula that's new minus old divided by old to get how many times as large or as small the new charge is as the smaller charge. And the new charge was 1.43373 times 10 to the negative 8th, and the old charge from the original lab was 4.87567 times 10 to the negative 9th. And by using that formula, we get that when modeled as a line charge, it is 1.94 times as large as when modeled as a point charge, as shown here. And the reason that these as estimates are not the same is because the model for the tapes as a line charge is more accurate, so it's the one that's closer to the real value, because a tape isn't ever just one singular charge since it's spread among the whole tape. So using it as a line charge would create the more accurate representation for the lab, which is why we got a much different number, and which is why it is 1.94 times as large.